In this tutorial, we're going to blink an LED. This LED on the Arduino is built in, connected internally to pin 13. Alternately, you can wire this circuitry up and blink an outboard LED. Just going to go over a breadboard really quickly. Breadboards are connected like this. All of these yellow dots are internally connected in the breadboard. Each row is connected to each other, and the rows on the other side of this line are connected to each other, but there is no electrical connection on either side of this middle divider. So that's the inside of the breadboard. On the outside, we have power rails. And so I'm going to click here, and you can see that all of these are wired together and all of these are wired together. Typically, these are used for what we call the rail voltage. In this case, it would be 5 volts and 0 volts. And then whenever you're wiring stuff up here, you can connect quickly and easily to the 5 or the 0 volts. I'm going to zoom in on the circuitry we have here, so it's a little bit easier to see. We have pin 13, as I said, is internally connected to this LED, but we can also connect it to this outboard circuit. So we're going to use this wire, come over here, and all of these green dots can show you that this wire is connected to each of these pins, and thus to this resistor, which comes over here into this row, connects to this LED, runs through the LED, and back to ground. It's a lot easier to see on the schematic. Here's pin 13 on the Arduino right here. It comes up, it connects to this resistor, goes through the LED, and back to ground. We've chosen a 220 ohm resistor. This resistor is here to limit the amount of current running through the LED. If we omit this resistor, what will happen is the LED will run an excessive amount of current. It will be really bright, but it will get too hot and burn up. So the resistor here is to prevent that from happening, to save our LED, and to keep the current within the operating current range of the LED. This symbol here is the symbol for an LED, and this is a symbol for a resistor. The LED has basically an arrow pointing in the direction of current flow. If the voltage on this side is higher than the voltage on this side, current will run through the LED in the direction of the arrow, and which is what we're going to do. We have 5 volts here and 0 volts here. So 5 volts comes up here through the resistor, and it's higher on this side of the LED than it is on that side, so current will run through. If the voltage on this side is higher than the voltage on this side, current will not flow through the LED. It's a one-way gate, essentially. So if you flip this LED around, it will not turn on. Let's go into the code and see how we're going to write the code for this. This is the old code that we'd written last time, where we set the baud rate for the serial port to 9600 bits per second, and we printed hello world to the screen. I'm going to quick upload this program to my Arduino. Now I should remind you that when you hook your Arduino up, always come in here, select the board that you're using and the port that that board is connected to before you try to upload. I've already done that, so here I can bring up the serial monitor, and it says hello world. Another feature, just to go over real quick, is here in the options, preferences. You can get to it by control comma, and in the preferences window, I'm going to bring that in here. It's a little bit hard to see, it's so small. I've set my editor font size to 16. I think it comes default something around 10, which is really hard for me to read, so I like to make it bigger. But if you have a lot of code, you may want it smaller to be able to read more lines at a time. But you have a lot of different preferences you can set here on the preferences screen. Okay, now let's move forward and write the code to blink this LED. In order to do that, we have to tell the code, the Arduino, that we're connecting here to pin 13. I'm going to go back to the breadboard view. So we need to tell it that we're going to turn pin 13 on and off. Pin 13 is a digital pin, as you can see here. What a digital pin means is that we can either have it be 5 volts or 0 volts, but nothing in between. That's different for these PWM pins that we'll go over in another tutorial. But pin 13 is not a PWM pin, so it can either be on or off. Those are our two options. So going back in here to the Arduino, we need to tell Arduino that we are going to use that pin. We use the keyword pin mode with a capital M, and we select the pin that we're going to to use, and then we tell that pin is going to be an output. And this will set the pin so that we can actually control the voltage on the pin. Then we come into the loop. What we want to do is we want to turn the LED on, wait for a little bit, turn it off, wait for a little bit, turn it on, and so on. So to do that, we're going to come in here and we're going to write this code. Digital write with a capital W. This is, there's another one, digital read. Digital read is going to look at the pin to see what voltage is on the pin. Digital write is going to set the voltage on the pin, which is what we're trying to do. We need again to tell it which pin we're writing to, and then we tell it to be on or off. The keyword for on is high, setting it to the high voltage of 5 volts. And then we're going to delay. We're going to wait for a little bit. The delay function takes in a value of milliseconds. There are 1,000 milliseconds in 1 second. So we're going to write that here. It's going to delay for 1 second. And then digital write pin 13 to low. Okay, this may seem like sufficient code to blink an LED. Here we're turning the LED on, we're waiting for a second, and we're turning it off. That should blink it. The problem here, and this is a common problem for people writing code, is they don't think too much about the amount of how fast this loop runs. So the way that code is read by the Arduino is line by line. So it's going to come in here to line 1. It's going to see the setup, and it knows to run the code between these two curly braces 1 time. So we'll set our baud rate to 9600. It will print to the screen hello world. We've added the ln here, so it will go to the next line. It will set pin 13 as an output, and then it finishes. It comes down to line 8, sees the loop, knows that it's going to run repeatedly the code between these two curly braces. It will turn our LED on. It will wait for a second. It will turn it off and immediately come back up and run line 9, which turns it on. So the time between turning it off and turning it back on again is almost non-existent. It is more or less immediate. So you won't see it turn off. It will do it. It will turn it off and back on again, but it will be so fast that you can't see it. In order for us to be able to see it, we need to put another delay. So I'm copying and pasting this delay again. So we're going to turn it on, wait for a second, turn it off, wait for a second, turn it on, wait a second, turn it off, so on. So I'm going to upload that to the Arduino, but you won't be able to see the LED blink. So in order for you to be able to see it, I'm going to print to the screen. And I'm going to say that the LED is on. And over here, I'm going to say the LED is off. Okay, so it's going to turn it on. It's going to print LED is on, and it will turn it off and say LED is off. And upload that code. Okay, so every second it's going to turn the LED on or off. And if you've wired this up, you can look and see that your LED is also blinking. Pretty exciting, pretty fun stuff. You can play around with these times. Let's just do one real quick here. We're going to turn it off for half the time that we're turning it on. So it'll be on for a second and off for half a second. And you can see that here in the display, how quickly it's transitioning from off to on again. And we can play around with this more. There's an interesting thing we can do with this code as well. We can actually dim the LED. The way we do that is by playing a trick on our eyes. Your eyes can see a certain number of frames per second. Your TV is turning frames on and off multiple times a second. I think that the refresh rate on a TV is about 60 hertz. It's similar with a light bulb. It turns it on and off 60 times a second. But you can't tell because your mind does not read that quickly. So we're going to do the same thing to our eyes. We're going to play a trick. We're going to turn the LED on for a little bit and then turn it off for a little bit. But we're going to make this time so small that our eyes won't be able to tell, and it will just look dim. So I'm going to play around with this value. I'm going to, let's make it 100 milliseconds on and 100 milliseconds off. I'm going to upload that and see what happens. Now, it's important to note that if you wired up this LED with this resistor, it will behave differently than this LED on here, because the resistance is maybe a little different, the brightness of the LED is different, so you'll see different results. I'm running the LED on my Arduino, so these values that I'm choosing are for that. Okay, you can see here that how quickly it's printing on and off, on and off, and this takes quite a bit of memory or space on the Arduino to type all this into the serial monitor. It's quite a bit of work, so we need to get rid of that. It slows the program down quite a bit to print things to the screen. So in order to do that, I'm going to I can either delete this line, or I can, if I want to use it again later, I can turn it into a comment. A comment is made like this. It grays it out. It's a line of code that you can read, but the compiler does not read. It just skips over this line. And so that's one way to do it. Another way is to use the control / here, and that creates the comment. You can highlight several lines of code like this, and control / it will comment them all out. It's a great way for you to write some code and get rid of it and then bring it back in easily. I'm going to comment out this line of code as well. And this is definitely not working for me. I can see the LED blinking. It's going way too slow. So I'm actually be able to pick up the blink of this LED. So I'm going to reduce this, and I'm going to only have it on for 10 milliseconds and off for 100. We'll see what happens here. Okay, now it's blinking super fast. I can see the blink. It's kind of annoying, actually. So this is too slow still. So I'm going to reduce it to 10 milliseconds. Upload again. 10 milliseconds is 1/100th of a second, to give you an idea for how fast this is going. Okay, now the LED, I cannot tell that it's blinking. It looks like it's just on. It's still pretty bright. So I'm going to reduce this now to 1 millisecond and upload this code again. So it's on for 1 millisecond and off for 10. And I'm looking at the LED and I can visually see that it is very, very dim, and I cannot tell that it's blinking. So it's a pretty cool thing that you can do. You can play around with these depending on what LED you happen to wire it up and see what values give you the best dimness. This is not the best way to write this code. In the next tutorial, we'll go over a better way to write this code.